This is work about a work in progress thing ongoing about SBCL, a top-like utility which is memory oriented. So maybe let's start with the top utility from, for example, Linux. There you see you can, with a certain option, you can already see threads of running SBCL, and you can even see some info about CPU usage per thread, but you cannot see anything about the different memory usage or allocation by the threads. So let's try to fix this. So first phase, what do we have? We have already in SBCL the possibility to enable a GC log file for garbage collections and a C-level function which produces a report to this file. It looks a bit like this. Some people in the room may recognize this. I'll say more to that later. The thing is, if we use the C-level function, and there is concurrent activity doing allocations going on, then it will at some point crash reliable very quickly. So what do? We lift it to Lisp level, and without these problematic assertions, and then it doesn't crash anymore. So here you can see this is a simple telnet session connected to a port of a running Lisp, which is obtaining every second this same dump, which is verified to be exactly the same as the C-level does. So what do we see here? Basically, we have the main dynamic space of SBCL, which is a huge chunk of memory. It's divided into a lot of equally sized pages. And these pages have two qualities. Each page has a page type to say what's allocated on it. For example, only conses. And a generation. So when you do generational garbage collection, things sink down from generation 0 to higher generations and at some point vanish if they become garbage. So what do you see here is basically a matrix where on the vertical axis you have the generations from 0 to 6, and on the horizontal axis you have, if you ignore the first three columns starting with boxed, you have the page types. So this is generations types times page types with page counts. But we want to see more detail. So what do we have about more detail? We have the Lisp level function room that gives us information about the contents of the entire heap. We want the same, but only for the results of some specific activity. So what do? SBCL is hackable, open source. We can add a new invariant to the garbage collector to keep separate stuff separate if it originates from separate activities, or in a different formulation, we just mandate the GC to not mix stuff together from different origins. So how does this look like? Let me add this a bit like this. So we have now a view where we can see different parts of the heap, which we call tracks. So for example, I can here start some worker thread which allocates some arrays, some worker thread which allocates some lists, and some worker thread which allocates some hash tables. And we see here in the listing below the first matrix that we can track them separately. So how does this work? We added a third page quality called tracks, and there are now two more projections from this now three-dimensional space. On the left, track times page type. On the right, track times generation. you can see them. One is from box to large mixed and one from Gen 0 to Gen 6. So we can go back. We even want to see more detail. So there's still the walk dynamic space provided by SBCL, and we can call it to memory contents filtered for a single activity. So in this case, for example, when we terminate all these threads and do a full garbage collection, we see that almost everything vanishes, and we have just a bit left. And if we now say, in track 1, we see there's only 2 conses left, and now we can say, show us, and it tells us, okay, we have exactly these conses. And now, shoot me.